So find the global maximum minimum to the function on the closed interval. And we are giving 1 of x equal to x to the 4 minus 8x squared on the interval minus 3 to 1. Here, note this is closed interval. That means we are guaranteed to find global maximum and minimum. And we will follow 3 steps to find global maximum minimum. First, we will find critical points, and then 2, evaluate critical points and the endpoint at the function. And then 3, decide what's a global maximum and minimum. The lowest value gonna be a global minimum, the highest value gonna be global maximum. So first, to find a critical point is where the first derivative is equal to 0 or undefined. So let's take the first derivative here. It's gonna be 4x cubed minus 8 multiplied by 2x. That's gonna be 4x cubed minus 16x. And then we can factor 4x, and they will left off with x squared minus 4. This is the first derivative. Now, note, whereas the first derivative is undefined, it's defined everywhere, including our interval, minus 3 to 1. Now, where the first derivative is 0, it's gonna be when 4x and then x squared minus 4 equal to 0. The first part gonna be when x is 0, and then the second term would gonna be when x squared minus 4 equal to 0, and we want to solve for x gonna be plus and minus square root of 4, which is gonna be equal to plus and minus 2. So we have 3 critical points in here, 0, 2, and minus 2. Notice that not all critical points on the interval. Plus 2, it's not on the interval. Therefore, it's not a critical point. So we only have 2 critical points, 0 and minus 2. Now, we are ready to move to step number 2. We're gonna evaluate our critical point, which is 0 and minus 2, and our endpoint, which is minus 3 and 1, in the given function f of x. After the evaluation, we're gonna look to the values of the function at these points, and the one with the highest value is gonna be a maximum point, and the one with the lowest value gonna be global minimum. So note here, minus 16 is the lowest value in here, and 9 here, this is the highest value in the evaluation. Therefore, step 3 is to decide what's a global maximum and minimum. So at x equal to minus 2, we have a global minimum. And then at x equal to minus 3, we will have a global maximum. Now, for part 2, we are giving the function x e to the minus x squared over 2, and the interval is minus 2 to 2. First, we will find the critical points. It's where the first derivative is 0 or undefined. Notice here, to take the derivative, we're gonna use the product rule. Since this is 2 multiply function, I'm gonna assign x to u and v to e to the minus square x squared over 2. Now for v, I'm gonna use the chain rule to take the derivative of the term. So the inside function gonna be minus 1 over 2 x squared. Now, after finding u prime, v, and v prime, we are ready to apply the product rule. Now we can simplify more. I'm gonna multiply the second term, which is x by x, gonna result in x squared. Now we can also factor the term e to the negative x squared over 2. Gonna be 1 minus x squared. This is the first derivative. Now, where's the first derivative is undefined, notice that the first derivative is defined everywhere, including on the interval -2 to 2. Now, where the first derivative is 0, that's gonna be when e to the minus x squared over 2 multiplied by 1 minus x squared equal to 0. Notice the first term, the e term, is never to 0. If you plug 0 for x, or negative value, positive value is not gonna be never 0. And then the second term gonna be 0 when x squared equal to 1, which is the same as saying x gonna be positive and negative 1. Notice now our critical point, which is 1 and -1, are in the interval that is from -2 to 2. Therefore, these are our critical points. Now for 3, actually this is for 2. What we're gonna do, we're gonna evaluate our critical point 1 and -1 and our endpoint -2 and 2 in the given function f of x. The highest value gonna be a global maximum and the lowest value gonna be a global minimum. Now these are the resulting numbers. So we notice here the lowest is negative 0.7607 and the highest is 0.607. Therefore, at x equal to 1, it's gonna be a global maximum since this is the highest value, and then at x equal to -1, it's gonna be a global minimum since this is the lowest value of the function. Now for part 3, we have this function x minus 2 natural log of x plus 1, and the interval is between 0 and 2. So first, we're gonna find the critical point. It's where the first derivative is 0 or undefined. So the first derivative gonna be 1 minus 2, and the derivative of natural log gonna be 1 over x plus 1. Now, notice this function is undefined when we have 2 over 0. So when the bottom term is equal to 0, that is when x equal to -1. Notice here, x equal to -1, it's not in the interval given. Our interval only from 0 to 2. Therefore, x equal to -2 is not considered to be a critical point. Now, where the first derivative is 0, gonna be when 1 minus 2 over x plus 1 equal to 0. And that gonna be when x plus 1 equal to the top, which is 2. So it's gonna be when we have 1 minus 2 over 2, which result in 1 minus 1 equal to 0. So we have to equal the bottom to 2, and will result in x, and move the 1 to the other side and result in x equal to 1. Notice 1 here, it's in our interval. Therefore, it's considered to be a critical point. Now for step number 2, we're gonna evaluate our critical point, which is 1, and our endpoint 0 and 2 in the function f of x. The highest value gonna be a global maximum, the lowest value gonna be global minimum. Here are the resulting numbers. We can see negative 0.386 is the lowest and 0 is the highest value. Therefore, at x equal to 1, we have a global minimum, and at x equal to 0, we have a global maximum. Now for part 4, we have this function x squared minus 2 and then absolute value of x, and we are giving the interval minus 3 to 4. So note here, the critical point is where the first derivative is 0 or undefined. But here, note this function, absolute value of x. So if we graph it, it's gonna look like the V shape. Notice here at x equal to 0, we have a sharp corner. That means the derivative at x equal to 0, it's undefined. Therefore, at x equal to 0, it's considered to be a critical point. And it is in the interval, which is from minus 3 to 4. Now, where's the first derivative is 0? Here we have two segments, when x is larger than 0 and when x is less than 0. So in case of x is larger than 0, f of x gonna be x squared minus 2x. Now let's take the derivative. It's gonna be 2x minus 2, and then this term gonna be 0. So we move minus to the other side and we divide on 2. That's gonna be x equal to 1. Note that x equal to 1, it's included in our interval, that is between minus 3 and 4. And then in case of x is less than 0, our function of x gonna be x squared and then minus 2 minus x, since absolute value of x on that side is negative. Now the first derivative gonna be 0 when 2x plus 2 equal to 0. That's gonna be when x equal to minus 1. And note here minus 1 is in our interval. So note we have 3 critical points here: x equal to 0, 1, and minus 1. So second step, we're gonna evaluate our critical point 0, 1, and minus 1, and our endpoints in here, which is minus 3 and 4 in the given function. This is the resulting values. So we notice here 8 is the highest value and minus 1, it's the lowest value. So at x equal to 1 and minus 1, we have a global minimum, and at x equal to 4, we have a global maximum.